Hey guys, it's Coach Brian going over the 3.2 practice. This is a pretty tough practice, pretty tough lesson overall, so it's really important that you understand it. You might need to watch this video once, twice, 3 times to make sure that you get it. I think the important things to note from this lesson in general and from 3.1 were, or the things to note would be that if you have 2 points, you can find the slope, okay? If you have 2 points, you can find the slope. If you have 1 point plus the slope, you can use the point slope form. And if you have slope intercept form, you can convert that to standard form. I'm out of paper to write that little note there. But that's kind of the key things to remember as we go along. Make sure you have your notes with you. You can still add to those and add information from these videos. So if I say something that really stands out to you, go ahead and write that down on your notes. If something's helpful to you or we work an example, I want you to be working it along with me. So as we start this first one, it has to graph the line 2x plus y equals 6. So currently, this equation is in standard form, and I want to get this into slope-intercept form, which is y equals mx plus b. So if you look right now, I've got my x and y on the same side, and for this one, I want the x to be opposite of the equal sign. So for this one specifically, I'm just going to take my 2x and move it to the other side of the equation, which would give me y equals negative 2x plus 6. And just by doing that alone, I was able to convert the standard form into slope-intercept form. And then if you remember, the slope is right there, m, and the y-intercept is right there, y equals mx plus b. So how would I graph this? The y-intercept is at positive 6, so I would put that right on the y-axis. And then my slope's negative 2, which if I wrote that as a fraction, I could write it as negative 2 over 1. And that would mean for my rise, I am going down 2, 1, 2. And for my run, I'm going over 1. So it would look like that, and I go down 2, over 1, down 2, over 1. And so you can kind of see my line forming right here. And let me see if I can get my ruler lined up. Go ahead and mark my line right there. All right, not perfect, but it's okay. So that's how that first one would work out, going from standard form to slope-intercept form and graphing the equation, or graphing the line of the equation. If I look over at number 2, it is in a weird form that, just from the day's lesson, I know that this one has confused a lot of you, but if you look at it, you still have y equals x, and you're trying to get y equals mx plus b, okay? And so we want to get y completely isolated, which means we need to get rid of this 2 in front of it. And since that 2 is currently being multiplied with the y, we need to do the opposite operation, which is to divide. Okay, so I want to get rid of that 2 by division. I think what a lot of you are missing, though, is that if I divide everything on the left side by 2, I need to also divide everything on the right side by 2. And so I get this equation y equals 3 over 2x, and I don't have a plus b. So if it helps you, you could just write plus 0, because it's plus nothing. And that lets you know that your y-intercept is at 0, which is the origin of the graph. And then using my slope here, okay, it's 3 over 2, so that's my rise over run. I would go up 3 over 2. And one thing I've been telling my students is that when you have a positive slope, okay, it's equivalent to a negative over a negative. Those are the same thing because negative divided by a negative is a positive. So that means for my slope, I could also go down 3 and to the left 2. And so that gives me a good solid number of points to just kind of map my line out here and graph my equation. So moving forward, I know I'm moving a little quick. I'm trying to keep the video pretty short. And if you need to go back, obviously rewind, slow down, whatever you need to do. Question 3 has a lot of information in it. It says to graph the line that's parallel to this one, and it goes through this point, -3, -1. So it's going to pass through that point. And I know from lesson 3.1 that when lines are parallel, that means they have the same slope. That's how I know that they're never going to intersect, touch, cross, is because they are they move at the same steepness and in the same direction. So really the first thing I've got to do is I've got to take this equation that's currently in standard form, and I've got to manipulate that so that it can be in slope-intercept form, y equals mx plus b. So I'm going to take this 6x plus 4y equals 8, and the first thing I want to do is get the x on the opposite side of the equal sign from the y. So I'm going to subtract 6x from both sides, and that gives me 4y equals -6x plus 8. 4y equals -6x plus 8. The next thing I want to do is isolate the y, which means I've got to get rid of the number in front of it. Right now they're being multiplied, so I'm going to cancel that out through division. But if I multiply everything on the left side, or excuse me, if I divide everything on the left side by 4, I've also got to divide everything on the right side by 4, including my number here at the end, my whole number. So once I do that division, I've got y equals -6 over 4x plus 8 over 4. And I can actually reduce both of those fractions. So the -6 over 4 can actually reduce to -3 over 2. And the positive 8 over 4 can actually be written as positive 2. 8 over 4 is 2. So those can both be simplified. And now I've got this equation in slope-intercept form. It says, my y-intercept is positive 2. My slope is down 3 over 2, down 3 over 2. And if I fully, sketch that line out, sorry for my rough sketches here, but if I sketch that line out, I know this other parallel line that the whole problem was about has the same slope. So from this known point, I can go down 3 over 2, down 3 over 2, and if you trace that out, you've got 2 parallel lines. 2 lines moving side by side, never crossing, never touching, with the same exact slope. All right, guys, moving ahead now. 4 is pretty easy. 5 is pretty easy. You're just going to look at the 2 lines, and you're writing them both in slope-intercept form. So the 2 main pieces of information that you need are going to be your y-intercepts, and then you're going to need to find the slope from rise over run on the graph. So I'm going to look down at 5 real quick. It's the next one that I consider, a little step up from those. And it says to write the equation of the line graph in standard form. So that means my final answer I'm trying to get in the form ax plus by equals c. And I also just, going off the rules, I want to have no fractions. And a is positive. A is positive. So what I want to do first is find my y-intercept, which is plus 2. because initially, just taking what I know, I'm gonna write it in slope-intercept form, and then I'm gonna convert it to standard form. So I've got plus 2 as my y-intercept, and then my slope, if you look, I'm just gonna try to find the next clear point that I cross, and then the next kind of clear point. And on this one, the line is slightly off. I apologize for that. But I'm going down 1, 2, 3, 4, and I'm going in a positive direction 1. So down 4 over 1, and just double check that again. 1, 2, 3, 4 over 1. So my slope is -4. So that's the equation of my line in slope-intercept form right here. Y equals -4x plus 2. Now I want to take that equation and I want to convert it to standard form. This one, thankfully, is pretty friendly. All I need to do is move that x value over to the other side. So the way I do that, I'm just going to rewrite it right here, -4x plus 2. Since it's a -4x, I'm just going to add 4x to each side. So I've got 4x plus 2, or excuse me, plus y equals 2. And just, double checking my rules, there are no fractions and a is positive. So that's my final answer for this equation in standard form. For the back page on our practice, it says, unless otherwise stated, write the equation of each line in slope-intercept form. So I'm going to be writing all of these in y equals mx plus b form. And let's go ahead and just look at all of them and see where it is otherwise stated. So 7 doesn't say, so it's slope-intercept form. 8, slope-intercept form. 9, 10 says standard form. So 10 is one of the ones where we will have a different form for our final answer. 11 and 12 don't say. 13, 14, 15, 16 says standard form. So it looks like those are our only 2. So everything else on here, unless I missed something, is going to be written in slope-intercept form. Now, initially, all right, it may seem like these problems are not giving you enough information to solve them, but trust me, there is enough information in each of them to find your solution. So the first thing on number 7 is that we have a horizontal line going through a given point, all right, going through a given point. So when we have a horizontal line from our 3.1 notes, we know that a horizontal line has a slope of 0 and is written as y equals something, okay? Y equals something. So just to help you visualize this, if we were to quickly graph this out, it goes through -2, -1. So it's a horizontal line. That's not a great point. Let me make that a little better. It's a horizontal line that goes through -2, okay? So completely flat line, slope is 0. And if I asked you, what is the y value of this line? Well, it's -1 here, it's -1 there, and there, and there. And pretty much because this line has no slope, it is a constant y value of -1. So you would write it as y equals -1. And that's your complete answer. Y equals a number is the equation of a horizontal line. Looking at 8, it says a line passing through 2 given points. And when I have 2 given points, all right, I kind of said this at the beginning of the notes, but when I have 2 points to start with, I can find their slope. That's the first thing I can do is find their slope. And so the slope formula is m equals y2 minus y1 over x2 minus x1. So I've been, encouraging my students to do this, but I think it's a good idea to label everything. x1, y1, x2, y2, and then you plug those numbers into your equation. So I'd have 3 minus negative 3 over negative 4 minus 4. So 3 minus a negative 3 is the same thing as adding 3. So that gives me 6. And then negative 4 minus 4 is going to make me more negative 6 over 8. And I already see that both of those are even numbers. And so that lets me know this fraction could be reduced. And they have a GCF of 2. So that means my slope is negative 3 over 4. 3 is my rise. 4 is my run. Excuse me. So that's not what it asked me to do yet, though. It asked me to find the equation of a line, and I know because it didn't state otherwise that I want it to be in slope-intercept form. And so what I can do next, since I have the slope and I have points, is I can use the point-slope form. Point-slope form. I may need some more room for this one, but point-slope form is y minus y1 equals m times x minus x1. So I've already got from my initial math here, a number labeled as x1 and y1. So I'm going to plug those in to this equation, and I know the slope, so I'm going to plug it into the equation. So y1 up here was negative 3. My slope is 3 over 4, and x1 from the same point is 4. So I'm going to distribute, and then here I've got subtraction of a negative, which is like a positive. And I don't have a ton of room, so I'm just going to write out post distribution what this should look like. I've got y plus 3 equals negative 3/4 x minus, so I've got negative times a minus. That means I'm going to end up having a positive y-intercept, and 3/4 times 4 is 12 over 4, which is 3. Now, there is one last step. I need to isolate y, so I need to go ahead and move this 3 over. And you'll see that 3 minus 3 actually gives me 0. It means that this whole graph goes through the origin. And I know that this is going to be, ugly, but I'm out of room. So I'm going to write my final answer in this box right here. It is y equals negative 3/4 x. And because the 3's canceled out, there is no plus or minus anything. It just goes through the origin. All right, moving on. For number 9, the question states that you're trying to draw the equation of a line that's perpendicular. That's what this symbol means. Okay, I just put it in there so you could start seeing it and understanding that when you see that symbol, it means that two lines are perpendicular. And it's got a slope of 2, and it passes through 5, negative 1. So first thing that I hope you remember from day 3.1 is that perpendicular slopes are negative reciprocals. Negative reciprocals. And what that means is that I told it to my class like this. And the negative means you're going to flip the sign. And the reciprocal means you're going to flip the fraction. Because even whole numbers can be written as fractions. So you're going to flip the sign and flip the fraction. So I'm going to erase this because it took my entire work area. So I'm going to take 2, which, because it's a whole number, is 2 over 1, and I'm going to flip it. And initially it's positive, so I'm going to make it negative. So negative 1/2 is the slope of this perpendicular line. So I have the slope and I have a point. And when I have a point and a slope, I can use point-slope form. Point-slope form is y minus y1 equals m times x minus x1. Where do my x1 and y1 come from? They come from this point that was given. So y minus 1 equals my slope, negative 1/2, times x minus negative 5. So if you are looking at this and you're recognizing, sorry about the bell, you're recognizing some distribution, that's 100% right. I've got y minus 1 equals, see how I've got negative minus a negative right here? That's going to be the same as plus. So when I distribute this, I've got negative 1/2 x, and I've got half of positive 5, which is going to be negative 5 over 2. The very last step of this one is to isolate y. So I'm going to add 1, which is the same as 2 over 2. And that gives me, again, I know it's ugly, but I'm going to write it right here in the margin. It gives me a final answer of y equals negative 1/2 x minus 3/2.